Hi guys, so I've got a lot of questions on Descartes' rule and the fundamental theorem of algebra in regards to your writing assignment. So I just want you to note a couple things before we start on the example. The fundamental theorem of algebra in layman's terms just tells you that the degree or the highest exponent of the function will tell you how many zeros to expect. Zeros are the x values when you solve for x or the x-intercepts. Now mind you, they can repeat, but it just tells you how many zeros to expect. Using Descartes, you can identify the number of possible, I should say possible, positive real zeros, negative real zeros, and complex zeros. So they're not actually going to tell you what the x values are. They're just going to tell you the number of possible combinations of positive, negative, and complex. Mind you, complex zeros will always come in pairs because you always have to have the conjugate. So expect an even number when it comes to complex zeros. So for the first example, I'm going to give you a rational function, or I'm sorry, a function of x to the third power plus 2x squared plus 5x plus 4. Now, using Descartes, we'll be able to identify the number of positive real zeros by counting the sign changes. So I'm going to write this function down, x to the third plus 2x squared plus 5x plus 4. Now, if I notice, when I go from one term to the next, it goes from positive to positive. So that's not a sign change. From here, positive 2x squared to positive 5x, it's still not a sign change. From positive 5x to positive 4, it's also not a sign change. So there are no sign changes here, which means there are 0 positive real zeros. Now, for step 2, we want to write f of negative x, meaning you want to change all the x's into negative x. So if I do that, negative x to the third power, notice that I'm writing all of the negative x values in parentheses so that the exponent can be assigned accordingly. So what do I mean by that? I mean that anytime you have a negative power and the base is negative, it's going to stay negative. Anytime you have a base that's negative and the exponent is even, it's going to be positive. Think about it. Negative x times negative x is positive x squared. And then 5 times negative x is negative 5x, and then bring down the positive 4, which is just the constant. And we're going to do the same thing we did in step 1. We're just going to count the number of sign changes. So from here to here, negative x to the third, positive 2x squared, got a sign change. Here, from positive 2x squared to negative 5x, there's another sign change. Here, from negative 5x to positive 4, we have 3 sign changes. So because there are 3 sign changes, that tells me that there are going to be 3 negative real zeros or 1 negative real zero. Why did that happen? Well, keep in mind, anytime you have positive or negative real zeros, they will come in either odd or even patterns. So let's say I had, for the first one, step 1, I had 5 positive real zeros. That means I had 5, 3, or 1. If I had 4 positive real zeros, that means I had 4, 2, or 0 positive real zeros. So they travel in even and odd patterns. And I'll tell you why in step 3. So don't stress too much. Just know that if they have an odd number, it travels in patterns, in odd patterns. So 3 or 1 negative real zeros. And then finally, you're going to use a table to determine the number of complex real zeros. So for this, I am going to use my fundamental theorem of algebra, which tells me the degree, or the highest exponent in my function, will tell me how many zeros to expect. So the total number of zeros I should expect is going to be 3, because the highest exponent is 3. So I'm just going to create a table off of that. Bear with me on this one. How many of them are positive? How many of them are negative? How many of them are complex? Okay, so from here, I'm just going to minimize this table. Bear with me. I have something on the bottom of my screen that doesn't let me see the bottom of this. So we'll go from here. Complex. Okay. So let's just try the first column here. We have 3 total zeros. We've already established that. Fundamental theorem of algebra tells me that I should have 3 total zeros. Now, from my work, I know that 0 of them are positive. How many of them can be negative? Well, I'm just going to take one of them, 3 of them. 3 of them can be negative. If I have 3 total zeros and 0 of them are positive and 3 of them are negative, how many are left over to be complex? None, because I'm supposed to have 3 total zeros and the negative took all of them. Now, my other list of possibilities is, once again, I have a total number of 3 zeros because, again, the highest exponent or degree is 3. We've already established 0 of them are positive. There's no going around that. Now, how many of them could be negative? Well, we also established that one of them could be negative. All right, well, if I have 3 total zeros and 0 of them are positive, one of them are negative, how many does that leave over to be complex? That would be 2, because total number of zeros is 3. I will only use one of them to be negative, which means that I have 2 left to be complex, which makes sense because complex numbers always travel in pairs, conjugates. It should be an even number. So these are my possibilities. All right, guys, hope this helps.